Good morning, friends. Today we are going to discuss unit number 2, actuator and power unit. So this is lecture section plan, unit 1 review, syllabus review, linear rotary actuator, some summary of sessions. Syllabus of second unit, actuator and power unit, linear and rotary actuator, types, construction, and characteristic, cylinder mounting, questioning of cylinder, power unit and accessories, types, types of power unit, reservoir assembly, constructional details, accumulators, intensifiers, pressure and temperature switches, sensors, lever sensor. Learning objective to understand actuators, to understand types of actuation, to understand construction and characteristics of actuator. At the end of session, student can understand actuator in fluid power system outcome. Also, student can know types of actuation system. Student will aware about construction and characteristics of actuator. So we are going to discuss actuators. What is the actuator? Actuator are devices used to produce action or motion. Input mainly electrical signal, air, fluid. Electrical signal can be low power or high power. Electrical signal can be low power or high power. Actuator output can be position or rate. That is linear displacement or velocity. Output of actuator can be position or rate or linear displacement or velocity. Actuation can be from few microns or few meters. From few micron to few meters. Actuator functional diagram, see control signal, unmodulated energy source, power amplification and modulation, energy conversion by actuator. This is output. See function of actuator, receive signals, amplified these, means micron convert into meter, convert into energy and give the output. This is function of actuator functional diagram. Actuators, hydraulic system are used to control and transmit power. Hydraulic system are used to control and transmit power, means control the hydraulic system and transfer the power. A pump driven by prime mover such as electric motor creates a flow of fluid in which the pressure, direction and flow rate are controlled by valve. An actuator is used to convert the energy of fluid back into mechanical power. See, a pump driven by prime mover, such as electric motor, creates a flow of fluid in which the pressure, direction, and flow rate are controlled by valves. An actuator used to convert the energy of fluid back into mechanical power. The amount of output power developed depends upon the flow rate, pressure drop across the actuator, and its overall efficiency. Thus, they are devices which used to convert pressure energy of the fluid into mechanical energy. Thus, the device which used to convert pressure energy into mechanical energy. See, this is photograph of actuator, compact actuator in NFP8 tie rod, rotary, guided rod, gripper, ISO, and rounded body. So types, depending on the types of actuation, hydraulic actuator are classified as linear actuator for linear actuations, rotary actuator for rotary actuations, semi-rotary actuator for limited angle of actuation. This is types of actuators: linear actuator, rotary actuator, semi-rotary actuator. Linear for linear actuation, hydraulic cylinder; rotary actuator for rotary actuations, hydraulic motor; semi-rotary actuator for limited angle of actuation, semi-rotary actuator. So hydraulic linear actuator, as their name implies, it provides motion in straight line. The total movement is a finite amount to determine by the construction of the unit. They are referred to as a cylinder, ram, and jacks. The function of hydraulic cylinder is to convert the hydraulic power into linear mechanical force. The hydraulic power extend and retract a piston rod to provide a pull or push force to drive the external rod along a straight path. This is hydraulic linear actuator. As their name implies, it provides motion in straight line. The total movement of finite amount determined by construction of the unit. They are referred to as a cylinder, ram, and jack. The function of hydraulic cylinder is to convert the hydraulic power into linear mechanical force by piston cylinder. So hydraulic cylinder extend and retract a piston rod to provide a pull or push force to drive the external rod along a straight path. Types of hydraulic cylinders. Hydraulic cylinder are following type: single acting cylinder, double acting cylinder, telescopic cylinder, tandem cylinders. Single acting cylinder, we can see here pressure port. Here, this is pressure port. This is piston seal. This is vent port. This is vent port. This spring and shaft, rod, spring, extension stroke in this rightward direction, and return stroke by spring inward direction. So see here, pressure port from here like that, and vent port. Single acting cylinder, it consists of piston inside a cylinder housing called as barrel. On one end is attached a rod which can reciprocate. At the opposite end, there is a port from entrance and exit of the oil. They produce force only in one direction by hydraulic pressure acting on the piston. The return of the spring is not done hydraulically. It is either done by gravity or spring. Double acting cylinder. There are two types of double acting cylinder. Double acting cylinder with piston rod one side. Double acting cylinder with piston rod on both sides. So double acting cylinder, this is piston rod in one side. So pumping flow in that direction. So pressure apply on these pistons, piston seal, piston, rod, extension stroke, and return stroke. Then piston move in this direction, extension. This is return stroke. See, pump flow in that direction and return flow in that direction. So this is the return stroke. So double acting cylinder with piston rod on one side. To extend the cylinder, the pump flow is sent to the blank end port as shown in figure. The fluid from the rod end port return to the reservoir. Now, to retract the cylinder, the pump flow is sent to the rod end port and the fluid from the blank end port return to the tank as shown in another figure. See, now to retract the cylinder, the pump flow is sent to the rod end port and the fluid flow bank input return to the tank as shown in another figure. See, this is return stroke here in that side. So double acting cylinder with a piston rod and on both sides. See, this is piston acting on both sides, rod on both sides. So rod, port, piston seal, this is port, this is rod, this is return stroke, this is extension stroke. So double acting cylinder, a double acting cylinder with a piston on both sides is a cylinder with a rod extending from both the end. The application involves in process where work can be done by both the end of the cylinder, thereby making the cylinder more productive. Means this cylinder is different from previous cylinder because here we can use working power for both sides. Double rod cylinder can withstand higher side load because they have extra bearing of each rod to withstand the loading. Telescopic cylinder. A telescopic cylinder is needed when a long stroke length and short retracted length are needed. The telescopic cylinder extends in stages, each stage consisting of sleeve that fit inside the previous stage. Telescopic cylinder is needed when a long stroke length and short retracted length are needed. The telescopic cylinder extends in stages, each stage consisting of sleeve that fit inside the previous stage. One application for this type of cylinder is raising a dumping truck bed. Telescopic cylinders are available both in single acting and double acting models. Telescopic cylinders are available both in single acting and double acting models. Telescopic cylinder, stage 3, stage 2, stage 1, and this is pressure port. This is telescopic cylinder. Here our target rod. This is 3 stages extension position. This is the retracted position of telescopic cylinder. For long length, we have used telescopic cylinder. Here, stage 1, stage 2, stage 3. So telescopic cylinder construction, they generally consist a nest of tube and operate on the displacement principle. The tube are supported by bearing ring, the innermost set of which have groove or channel to allow the fluid flow. The front bearing assembly on each section includes seal and wing ring. Stop ring limit the movement of each section, thus preventing the separation. For a given input flow rate, the speed of operation increases in step as each successive section reaches the end its stroke. Similarly, of specific pressure, the rod shifting capacity decreases for each of the successive sessions. The tube are supported by bearing rings, the innermost set on which have grooves of china to allow the fluid flow. The front bearing assembly on each section includes seals and wing wiper rings. So stop ring limit the movement of each section, thus preventing the separation. For a given input flow rate, the speed of the operations increase in step as each successive session reaches the end of each stroke. Similarly, for specific pressure, the rod shifting capacity decreases for each of the successive sessions. Tandem cylinder. See here, tandem cylinder. This is inlet port, this is outlet port. See here, tandem cylinder pressure on this piston. Also here from here, this is also for inlet port. This is outlet port of the liquid. This is inlet port. This is outlet port for double pressure. Tandem cylinder. Tandem cylinder is used in an application where large amount of force is required, because to see here we can apply double force here. See, this is inlet of fluid here, pressure applied on these pistons. See, also pressure applied on this piston. See, like that. So this is double force is required to apply it from a small diameter of cylinder. Pressure is applied to both the pistons, resulting in an increased force because of large area. The only drawback is that this cylinder must be longer than standard cylinder to achieve an equal speed, because the flow must go to both the pistons simultaneously. So, graphical symbols of the cylinder: single acting cylinder with unspecified return stroke. See, like that. This is symbol of single acting cylinder with unspecified return stroke. Second, single acting cylinder with spring return. Single acting cylinder with spring return. Double acting cylinder with single piston rod. This is double acting cylinder with double piston rod. This is telescopic cylinder. Telescopic cylinder. Telescopic cylinder, single acting. Telescopic cylinder, here double acting cylinder, fixed cushion on one side. Fixed cushion on one side. Double acting cylinder, variable cushion on one side. See. And double acting cylinder, variable cushion on both sides. Right there. After that, symbol cushioning of cylinder, cushion sphere. See here, this is cushion sphere, cushion port, cushion sphere, retraction stroke, and cushioning adjustment restricator. Cushioning of cylinder. For prevention of shock due to stopping load at the end of piston stroke, cushioning devices are used. Cushion may be applied at either end or both ends. They operate on the principle that as cylinder piston approaches the end of the stroke, the exhaust fluid is forced to go through the adjustable needle valve that is set to control the escaping fluid at a given rate. This allows the declarations characteristic to be adjusted for different load. When the cylinder piston is actuated, The fluid enters the cylinder port and flow through a return check valve so that the entire piston area can be utilized to produce force and motion. For see here, for prevention of shock due to stopping load, at the end of piston stroke, cushioning devices are used. Cushioning may be applied at either end or both ends. They operate on the principle that as cylinder pistons approaches the end of stroke, an exhaust fluid is forced to go through adjustable needle valve that is set to control escaping fluid at the given rate. This allows the deceleration characteristic to be adjusted for different load. When the cylinder piston is actuated, the fluid enters the cylinder port and flow through return check valve so that the entire piston area can be utilized to produce force and motion. Operation of cylinder cushioning. See here, exhaust flow passes freely out of the cylinder. See like that. This is cushioning. Yeah. Operation of cylinder cushioning check valve allow free flow to the piston to extend. See, plunger enter the cap, this cap. No number of flow take restricted path causing the piston to decelerate. Rate of deceleration can be adjusted here. Check valve allow free flow to the piston to extend. Cushioning pressure. During deceleration, extremely high pressure may be developed within a cylinder cushion. The action of the cushioning device is to set up a back pressure to decelerate the rod. So maximum speed in cushion cylinder, the maximum speed of the cushion rod is limited by the rate of fluid flow into and out of the cylinder and the ability of the cylinder to withstand the impact force that occurs when the piston motion is arrested by the cylinder end plate. For uncushioned cylinder, 8 meter per minute. For cushioned cylinder, 12 meter per minute. For high speed or extremely cushioned cylinder, 30 meter per minute. Acceleration and deceleration of cylinder rod. Cylinders are subjected to acceleration and deceleration during their operation. Cylinders are decelerated to provide cushioning, and cylinders are accelerated to reduce cycle time of operation. Acceleration equation V equal to U plus AT. So V equal to U plus AT. Second, V square equal to U square plus 2AS and S equal to UT plus 1 up AT square. Questions. Explain. This is question for you for your homework. Write down this. So any question, answer, please ask me. Thank you. So today we have stopped here. Any doubt, any queries, please ask me.